All right, are we ready to get into probability? I think it's getting a little more interesting now, right? So probability is a very important fundamental concept in statistics, essential element in statistics. So you need to have a very good understanding of about the probability as we go on. Okay? But I'm sure most of you have pretty good ideas about the probability already. You've used this term many times, okay, in your life. You've used the concepts, I guess, maybe every day. Right? All right. Probability is the chance or likelihood that an uncertain event will occur. Okay? It's always between 0 and 1. If you say probability is 0, that means there is absolutely no chance, no possibility that the event will occur, right? If it's 1, that means it's a certainty, okay? It will always happen, no matter what, okay? In statistics, we typically say there are 3 different approaches through which we come up with the probability of an event, okay? And these are the 3 different approaches. Okay? A priori approach in calculating probability is using prior knowledge, something that we already know. Okay? And many times it's called the classical approach. Yeah. This method relies on mathematical regularity of an event. Mathematical regularity of an event. Okay? So sometimes we call it symmetricity. Symmetricity. Okay? What are we talking about? Based on what we know, or based on the design of the event, we can logically figure out the probability. Okay? For example, suppose you are rolling a dice. Dice. Okay? How many possible outcomes are there? 6. You will get either 1, 2, 3, 4, 5, or 6. Right? So what is the probability that you will get 3 when you roll a die once? Right? What's the chance that you will get 3? As an outcome? 1/6, right? So, well, assuming that the dice is fair. What do we mean by fair? Fairness. Okay? That means all those 6 outcomes, okay? Each outcome is equally likely, right? That's what we mean by fairness of a dice, okay? Or symmetricity. That's what we mean by symmetricity here. Okay? All the outcomes are equally likely. Mathematical regularity. Okay? So based on that, we can figure it out. Okay? Example here is probability of selecting a face card. Well, we're going to use this playing cards as a tool in this class many times. So, well, just let me introduce. Just in case you have never played the cards, right? Goes from A1 through 10, and Jack, Queen, King, right? So we have total of 13 cards in each suite, okay? And there are 4 different suites, you know, right? Diamonds, hearts, and clubs, and spades. Okay? These 2 are red, these 2 are black, right? So if you know that, if you remember that, I guess you have necessary knowledge about the playing cards. Okay? All right, so face cards, what they mean by face cards, Jack, Queen, or King. Or when we were playing cards in college, we called them 그림. Picture cards, right? Okay. Okay. So what's the probability of selecting when you, so total of 52 cards, you know, because we have 4 suites. That's 52, right? There is so each deck of a card is, contains 52 cards, right? So when you pick a card randomly from one deck of a card, right? What's the chance, what's the probability that you will pick a face card, right? Well, there are a total of 12 face cards, right? 3 in each suite, right? Out of 52, that's 3 out of 13, okay? So we can logically figure out the probability. That's what we mean by a priori probability approach or classical approach, okay? You know, you can think of many different examples, like tossing a coin. How many possible outcomes if you toss a coin? 2, either head or tail, right? Which one is head and which one is tail? Many times a coin has somebody's head or figure on one side, okay, and other thing on the other side, okay. So anyway, so if the coin is fair, then we can also figure out the probability, right? Probability for head is 1/2, probability for tail is another half, right? If you, yeah, so we're going to use that example many times, okay? All right. Next approach is called the empirical probability or empirical approach. Okay? Empirical means experience. Okay? So this probabilities are assigned based on observed data or based on experience, okay? Or past history. Okay? That's what we mean by empirical approach. Okay? So let's say we have total of 439 students classified in this, what do we call this? What do we call this table? Contingency table, right? We have classified 439 students by 2 different categories, 2 different criteria, okay? Male, female, so total of 229 male students and 210 female students, right? And also by whether they're taking stats or not, okay? So apparently 160 students out of 439 are taking stats, okay? And the rest, 279, are not taking stats, okay? All right? So based on this, we can figure out the probability, whatever the probability may be, right? Number of males taking stats, right? Or find the probability of selecting a male student taking statistics from a population, right? All right? So then using this table, right? Out of 439 total students, we have 84 male students who are taking stats, right? So we can simply divide 84 by 439, and we come up with 0.191, right? So out of those total 439 students, when you pick one student at random, say you had all those numbers, names in a box, and without looking into the box, you picked one name, right? What's the probability that that particular name is a male student, right? Who's taking statistics, right? Then we can calculate the probability that way. Yeah? This is probably the most common way of assigning the probability in reality. Yeah? Insurance company uses statistics a lot. Have you ever heard of actuary? Actuary. A-C-T-U-A-R-Y. Actuary. It's the name of a profession. I think in Korean language it's called the 요율사. Something. Huh? 계리사? Okay. Is there something like 요율사? No? Maybe not. Okay. 계리사. Okay. Yeah, and maybe some of you are interested in becoming an actuary, right? In the United States, if you want to become an actuary, you have to pass 10 exams, right? But once you pass first 5 exams, you can actually start working, okay? As an associate, right? And, there are a total of 10 exams, okay? That takes a lot of effort and time, okay? But reward is also great, okay? The salary is extremely high, okay? Probably one of the highest paid job. Okay? And what they do is they calculate probabilities for insurance companies and some other related businesses. Okay? So, let's say we're talking about fire insurance. Okay? If you buy your house and you get your house insured by a company, then you get a bill for the premium. Okay? Say you need to pay $300 per year. Okay? How did they come up with this $300 per year? Or if you buy a car, you get an insurance, automobile insurance, right? At your age, I'm sure you'll find the premium is extremely high, right? Sky high. Okay? When I first bought the car for my son, it was like my premium was about $100 a year, right? But he had to pay about $1,200 per year, right? About 12 times high than my insurance, right? So how do they come up with the premium, right? It's all based on probability. What's the probability that this particular type of house in this particular location will catch fire, right? Well, how do they come up with that probability, right? Using past history. Okay, using the records in the past, right? So, in this area, suppose they have insured 1 million houses during the last 20 years, okay? And let's say one out of 10,000 houses caught fire in this particular type of housing. There are brick houses, there are frame houses, and different structures, and what's the fuel? Do they use oil for the heating, or gas for the heating, or electricity, and so on, right? So using all those conditions, they come up with this chance, probability that this house will catch fire within a year, okay? And then they multiply this probability to what? They will multiply this probability to any idea?
Cost of compensation.
Right, or value of the house, right? Suppose the value of the house is $300,000. So in case this house is completely lost, they have to compensate $300,000, right? So if you multiply that, it's going to be what? It's going to be pretty cheap, right? $30? Yeah, something like that, right? And of course, they have to add up their administrative cost and other things, right? Right. So that's how the empirical approach is used to come up with probability. Yeah? You know, young people, especially teenagers, they charge a lot for automobile insurance because, you know, you can cry and you can scream that, you know, this is a discrimination, age discrimination, right? But the fact is, young people, especially teenagers, get into a lot of accidents, right? They are so busy, you know, texting and, you know, doing some other things while driving, right? I guess so many things are on their head, right? And I am a 30-year accident-free, perfect driver, right? My son got an accident, well, not a big accident, a small, you know, scratches, really needless accidents, about 3 times in 3 years. Yeah? So his premium is still very high. Yeah? Okay. Last approach is called the subjective approach. Okay? This is, you know, this is the case where we cannot apply first 2 approaches, neither a priori approach nor the empirical approach. Okay? Because this particular event's conditions and circumstances are unique. It never happened before. We never had the same situation before, okay? The first time event, okay? Or there have been some similar events before, but, you know, not exactly the same. At this time, some conditions are different, right? So what do we do in such cases? We have to use we have to combine everything that we know. We have to use logic. In other words, we can bring some concepts from a priori approach, right? If we can come up with any mathematical regularity, right, for the event, we'll use that, right? But then we have to use some other subjective judgment, okay? So something, you know, good example is probability that a new product development project will succeed, okay? You are developing a completely new product, okay? This kind of product has never existed before, right? But in order to come up with the probability of the cost, you know, what's the cost will be, and you know, whether this development is profitable or not, you'll have to come up with the probability of success, right? But unfortunately, you don't have past history, right? So you'll have to use all kinds of judgment, including your subjective judgment, right, to come up with the probability of success. Okay? Probability that Professor An, you know who that is, will be the next president of South Korea. Well, never happened before. We never had, you know, this kind of situation, right? So, you know, they always come up with, there are people who come up with the probabilities for these things, right? But, you know, they'll have to use their subjective judgment, okay? You know, there were some cannonball exchange yesterday on the West Coast. Have you heard the news? Right? Some exchange of fire between North Korea and South Korea, right? And looks like it's just an annual event, right? Last year at about this time, you know, I was really scared. And you know, the U.S. Embassy sends out this email, right? And I was tuning into U.S. Embassy announcements every day in case war breaks out. Yeah? American citizens are supposed to come someplace, and some, you know, transportation will be provided for, you know, American citizens to evacuate. You know, and so let's say if someone asks, what's the probability that there will be a war in Korean Peninsula within the next 6 months? Well, there is no, well, there have been war on Korean Peninsula, right? But it was not exactly the same situation, right? So you'll have to use a subjective judgment in coming up with such probabilities. Okay. Okay. Let's get down to some details. Okay. So there are some terminologies, concepts you'll have to get used to as we go on. Okay. First of all, event. Event means each possible outcome of a variable. Okay? So something like rolling a die or dice. Okay? And we already talked about there are 6 possible outcomes, right? So each of them is an event. Okay? Simple event is an event described by a single characteristic, right? Something like event where a red card is drawn from a deck of cards. Okay? When you pick a card, it happens to be red. Okay? That's an event, a simple event. It cannot be divided further. Right? It is not a combination of any multiple events. It's just a simple one single event. Okay? Just red card. Okay? Joint event is a combination of 2 or more characteristics. Right? So something like you're picking a card that is an ace and it is also red. Okay? So many times we illustrate these events using Venn diagram. I think you probably learned this in high school, right? Venn diagram. Okay? And we illustrate the sample space. I think. Yeah, sample space is the collection of all possible events, right? So in the case of rolling a die, right, there's 6 possibilities, 6 outcomes or 6 events constitute the sample event, sample space. Okay? In the case of playing cards, the 52 cards, okay, constitute sample space, right? And in Venn diagram, we represent the sample space by a rectangle, okay? Sample space. Okay? And then we usually draw a circle to represent an event, okay? Let's say A. Here's an event A. And A can be defined many different ways. Drawing a red card. That's a simple event. Okay? And you can also calculate the probability easily in this case, right? What's the probability of A? We're talking about drawing a cards out of a deck of cards. Okay? Out of 52 cards, how many red? 26, exactly half, right? There are only 2 colors, right? Either red or black, right? And they are symmetric, right? So probability of A, we know that it is 1/2. Okay? Well, of course, the size of the circle is not exactly 1/2 of the sample space, but don't worry about it, right? We don't have to be exact, right? Okay. Complement. That is what's called the complement of an event. We denote it with the A prime. Okay? A prime is the opposite of A, if there is an event, right? Something that A will not happen, the probability that A will not happen, right? So here, what is A prime? If event A is the event of drawing a red card, right? What is A prime? Drawing a black card. Okay? So anywhere outside A, we can say that's A prime. Okay? In Venn diagram. Okay? Okay. Now, let's bring in another event. Here we have another event, right? That is an event that your card is an ace. Okay? I can write it that way or draw it that way. Okay? So I drew it so that there will be an overlapping area between A and B. What does that mean? Why did I draw it that way? Why didn't I draw it like this? I say this is correct, this is incorrect. Why? What do we? Okay, what will be the common? Card is what? Red? Right. Well, this A is red, right? The entire A is red, okay? But some of them are also ace, right? So this particular area, the overlapping area, that includes those cards that are red and ace, right? Okay, that's the idea of joint probability, okay, or joint event, right? So we can simplify the Venn diagram. Like here, we have A and B, and this overlapping area represents joint event. Okay? And, well, we can say P, A, joint B. Are you going somewhere? Why are you standing? Hey, are you okay? Okay, right. All right, so this is a symbol. We read it as joint. Joint, A joint B. Okay? Or A and B. Okay? Which means this is the case. This is the event A and B occur at the same time. Okay? All right. So we talked about the sample space already. And let's use the same example to discuss it further, all right? Because there are different ways of visualizing events. You know, first way is using the tabular approach, using the contingency table, right? We can classify 52 cards by the color, black, red, okay? Of course, they are 26 each, okay? And ace, not ace. There are only 4 aces, right? 1 ace for each suite, in each suite, okay? So there are a total of 4 aces and 48 non-aces, okay? So we can calculate the probability anyway, right? What's the probability that that you will pick a card which is red and an ace, right? That's 2 out of 52, right? 2 out of 52, which is 1 out of 13, right? That makes sense because there's only 1 ace every 13 cards, right? Out of each suite, right? what's the probability that you pick a card which is red, and that is not an ace? It's 24 out of 52, or 12 out of 13, right? Something like that. Oh, 12 out of 26, sorry, right? 1 out of, 26. Oh. All right. So using this contingency table, you can ask and find many different probabilities, right? Another way to visualize or illustrate the probability or events is using the decision tree. Okay? So out of the full deck of 52 cards, we think about the first possibility. It's called the node. Okay? Node is the place where each branch come out, or each branch comes out, right? So out of the first node, we have black card possibility, red card possibility, right? And then among the black cards, some are ace, and the rest are not an ace, right? So we can represent it this way, okay? And we can also calculate the probability for each possible outcome, right? And we'll talk about that later in the later chapter, okay? Or later in the chapter. Any questions so far? We're getting a little bit faster here. Okay, so simple probability is a probability of a simple event, something like probability of an ace, or probability that you will pick red cards, right? And you can find those probabilities on the margins of a contingency table. As you see here, probability that you will find a red card is 26 out of 52, right? Probability that you will pick an ace is 4 out of 52, right? So those numbers, I mean, these rows, the total rows here, right? These are also called the margins, right? And excuse me. We'll talk about marginal probability soon, right? So the name comes from here, right? We find the simple probabilities on the margins. Okay? Well, remember, these numbers are not simple, right? These are joint events, right? This is an event that you will have an ace and black, not ace and black, and so on, okay? But simple probabilities are found on the margins, okay? Yeah, we talked about joint probability already. All right, so let's skip this slide. All right, mutually exclusive events. Here are a couple of interesting and sometimes confusing concepts. Okay? Mutually exclusive events are events that cannot occur simultaneously. We're talking about two events or multiple events that cannot have any joint events. They cannot occur at the same time. If one event occurs, right, the rest of the events cannot happen. Okay? So let's say A is defined as a joint event, right? It's actually union, okay? Hearts or diamonds, in other words, it's a red card, right? Hearts or diamonds, that means the card is red, okay? Event B is spades or clubs, okay? That means the card is black, right? So if you pick the card and one of these two events occurred, it happened to be black, right? Then obviously you cannot have at the same time another event, right? It's either black or red, right? You cannot have an event something like red and black, right? Make sure you understand that, right? We talked about this joint event. A is red, B is ace, right? It is possible to have those joint events, right? Just because you picked a red doesn't mean it cannot be an ace, right? But if you define events this way, red cards, black cards, then obviously there cannot be any joint events, right? They are mutually exclusive, right? So if you draw the Venn diagram in such case, it will be A, B. There will be no overlapping portion, right? Okay? That's the idea of mutually exclusive events, right? You can have more than two events that are mutually exclusive, right? If you define event A is ace, that's an event that you pick ace, right? Event B is a face card, right? And event C is, let's say, even numbered. Even numbered cards. Okay? Then, well, even numbered card means either 2, 4, 6, 8, 10. Right? So these three events will be mutually exclusive. Right? Because they cannot occur at the same time. None of those two events can occur at the same time. There will be absolutely no overlapping portion. Right? Okay? Collectively exhaustive is slightly more confusing for some of you. Okay? Collectively exhaustive means one of these events must occur. If you have two events, right? Two events will cover entire area. So something like A and B. Right? There is no other area that is uncovered by these two events. So between A and B, they exhaust all possibilities. There is no other possibility, right, left uncovered by these two events. Right? Well, here this is a special case. If I draw it this way, you can say these A and B are, first of all, mutually exclusive, right? Because there is no overlapping portion, right? But then they are also collectively exhaustive, right? Because there is no other possibility, right? There is no room for other possibility. The A and B cover entire area, right? So this is the case where A and B are mutually exclusive and collectively exhaustive. Special case, right? Well, actually, the one I used here, the example, A is being red card, B being black cards, right? They are collectively exhaustive and mutually exclusive, right? If you think about it, right? If it's a red card, you cannot have black card at the same time, and it's either red or black. There is no other possibility, right? Okay, but not all mutually exclusive events are collectively exhaustive, or vice versa, right? Not all collectively exhaustive events are mutually exclusive. Think about this example, right? Suppose we have 4 events. A is the case where you have aces, okay? B is black card, C is diamond, D is heart, okay? Can someone come out here and illustrate this in Venn diagram? Extra credit. Yeah. Here's the sample space. Can you illustrate A, B, C, D in that space? You want me to turn off the camera? Okay, you want to try? Go ahead. Let's see, 최봉호, right? Okay, you get credit anyway, right? 최봉호. Wow. I think that's perfect, right? You understand? Okay. So, yeah, first of all, he divided the entire space between B and CD, right? And B being black, it's half of the cards are black, right? And C and D, diamonds and hearts, they cover entire red cards, right? So C and D. So you can say B, C, D are what? B, C, D are mutually exclusive, right? Right? Because once you have a black card, you cannot have diamond, right? It cannot be diamond, it cannot be heart, right? And once you have heart, you cannot be diamond, vice versa, right? So B, C, D are mutually exclusive. There is no overlapping portion, right? But they are also, what? Collectively exhaustive, right? Because these three events, black cards, hearts, diamond, right? They cover entire area, entire 52 cards, right? So B, C, D are mutually exclusive and collectively exhaustive, right? But what about A? A is an event you pick an ace, right? And you have an ace in every street, one ace in every street, right? So this is exactly the way you should illustrate, right? A overlaps with B, C, D, right? Okay, very good, right? Make sure you understand, right? Well, one last comment here. In case some events are both collectively exhaustive and mutually exclusive, then probabilities of all those events, when you add them up, it will be exactly 1, right? It will be exactly 1, something like this, right? We have B, C, D. Those three events are collectively exhaustive and mutually exclusive, right? And those three events cover entire sample space, right? So that's 100% or 1, probability of 1. Okay? No less than 1. Okay? All right. Let's just make it our last slide today. Okay? This is what I talked about, right? When you have a contingency table, right? Those numbers inside, those spaces inside, represent joint events, because in order to be here, it has to be ace and red, right? Ace and black, and so on, right? But those cells that are on the margins, right? Those are simple events, right? This is the simple event that a card will be an ace, non-ace, black, red, right? So simple probabilities are also called the marginal probabilities here. Okay? So if you divide it by the total, you get the simple probability of ace. That is 4 out of 52. Of course, you can add them up, this one plus this one, right? You can do it that way, right? So here, we come up with an interesting formula here, right? Probability of A is probability of A joint B1 probability of A join B2, and including up to all the possibilities of possible events in B, possible outcomes in B, right? Where B2, B1, B2, Bk are K mutually exclusive and collectively exhaustive events, right? It sounds a little bit complicated, but look at this Venn diagram. Okay? We have event A defined here. Remember, A is the probability that, or event that you pick on ACE, right? And then we have B, C, D. And these three events are mutually exclusive and collectively exhaustive. Okay? Then, if you think about the joint probabilities, probability between A and B, and probability between A and C, and probability between A and D, there are three joint events, right? So if you add them up, what do you get? In other words, if you add the probability between A and B, this area, plus the joint event between A and C, this area, plus joint event between A and D, this area, what do you get? Probability for A, right? That's it. That's probability for A, right? That's what we have here. That's the rule about the marginal probability, right? So you can understand it using contingency table this way. If you like, you can construct a contingency table using this example, right? But, that's how it comes out, right? So that's what we call marginal probability. Again, marginal probability is a simple event. I mean, the simple probability. It's a probability of a simple event, right? But you can come up with the marginal probability this way. You might think, that's a little bit roundabout way. Why make it so complicated? It's a simple concept, right? But we need that for our ultimate goal in this chapter. If you read the chapter, the final topic is Bayes' theorem. Okay? When you, in order to understand the Bayes' theorem, how to use Bayes' theorem, you need to understand the concept of marginal probability, this idea. Okay? Any question? All right, we'll have a review session on Thursday. I'll see you on Thursday.